Welcome to Reasonable Data Science. In today's video, we're going to have fun building a regression decision tree to try and predict home prices. Before we can build the regression decision tree, we need to load the proper libraries. If you've been following along in my other videos, you'll be familiar with some of these libraries that I've highlighted here. The new library that we're going to be importing for this video is from the sklearn.tree, and then we're going to import the DecisionTreeRegressor. This right here will allow us to create our regression decision tree. After we load the proper libraries, we can then load the data set. And down here is an output of the data set. So what we're going to try and predict is this price variable. And what this data set shows is the price of homes that have sold, and then some of the attributes of those homes. What's nice about regression decision trees is that you do not need to create individual dummy variable columns like you would with a linear regression model. So as you can see, jurisdiction here looks like it's text data, and same with residence types. So instead of creating a bunch of dummy variable columns, what we can do is we can just overwrite the text data with numeric values, integers, that will correspond to those individual cities. So if we were to say df jurisdiction.unique, we could see that there's 3 different unique cities in that column here. If we were to do the same for the residence type, you'd see that there's 2 unique values for that. So all I'm going to do is I'm just going to overwrite these 3 unique values in city and these 2 unique values and assign them in a number. So the function I'm going to use to do that, I'm just going to say jurisdiction equals, and then in braces, city A, and then what you want it to be called. So we're going to call city A1, and then we're going to do city B, call it 2, and then we're going to do city C, and call that 3. And then what I'm going to do is I'm just going to do df jurisdiction, set it equal to itself, and then say dot map, and then we're going to map in the jurisdiction variable that we created above. And so now if we were to rerun our df jurisdiction unique, we get 3 for city C, 1 for city A, 2 for city B. And then I'm just going to copy the same one here, and we're going to do the same for residence types. So I'm just going to say residence, and then I'm just going to come up here and copy 2 stories. Is going to be a 2, and then 1 story is going to be a 1. And we can get rid of this one here. And then we're going to say df of residence type. So we're going to overwrite the column with itself. And then we're going to say map residence. And so now if we were to run the residence type unique again, we get a 2 and a 1. So that's a really nice thing about regression decision trees, is none of those dummy variables. After we've cleaned up our data set here, we can now build our Y and our X data sets, which we're going to use those to create our training and our test data sets on. So I'm going to say Y equals df of price, X equals df of iloc, and then colon, comma 1, colon. And then if we run that, if you wanted to look at what like the X looks like, we could say x.head just to make sure it loaded correctly, and it grabbed all the columns excluding price. If we looked at y.head, that's just the variable we're trying to predict. All right, so now that we've created our X and Y, we can create our training and our test data sets. So we can say X underscore train, X underscore test, Y underscore train, Y underscore test, and set that equal to the train underscore split, or train underscore test underscore split. We're going to be splitting our x and our y that we created above. We're going to be using a test size equal to 0.2 and a random underscore state, we're going to say equals 0. All right, so let's run that, and then we can just quickly look at our xtrain data set just to make sure it looks okay. Yep, that's all the columns we're going to be using to predict home price. If you want to look at the y underscore train dot head, that's just the price column there. And the training data set should have 80% of the rows since our test data size here is set to 20%. So we grabbed a random 20% of the rows, put them into the test, and then we grabbed the rest of the 80% and put them into our training data sets. After you set up your training and test data set, what we can do now is we can set up our regression decision tree. To set up a regression decision tree, I'm going to first create a variable that we're going to stuff the decision tree into. So I'm going to call it dtree, and I'm going to set that equal to DecisionTreeRegressor. And make sure you capitalize the D, the T, and the R in DecisionTreeRegressor. So the first decision tree we're going to make is going to be simple. So I'm going to say max underscore depth equals 3. So what that's going to do is going to limit the regression decision tree to only having 3 levels below the leaf node or the root node. Then I'm also going to say min underscore samples underscore split. I'm going to say equals to 5. And so that's going to require at least 5 observations before a decision node can be split again. Then what we need to do is we need to fit the dtree. So we're going to say dtree equals dtree.fit. And then we're going to say x underscore train. And then this is where we're going to list the variables that we want to use to predict our home price. So we're just going to start out and say total underscore living underscore area. I'm going to say jurisdiction. Say residence underscore type. And I'm going to say bedrooms. So those are just the 4 variables we're going to use to predict our home price. So then we're going to say, after that, we're then going to say y underscore train and close off the parenthesis there. So let's run that, and you won't see anything, but what that's done is now that's set up our decision tree. So what we can do is we can plot the decision tree. But what I like to do before plotting the decision tree is I like to add a labels variable. And within the labels, we're going to say labels equal, and then we're just going to copy the labels that we have up in our decision tree model up here. And so what that's going to do, it's going to then add these labels to our decision tree output, which makes it a lot easier to read. So to plot the decision tree, all we need to do is we're going to use tree.plot underscore tree. Then we're going to say dtree. Then we're going to say feature underscore names equals our labels, which is what we have up here. And then to make it a little bit nicer looking, I'm going to say filled equals true. And then you just say plt.show. And when you execute that, it might take a second, but you'll get a decision tree. But this one isn't very nice looking, so let's adjust the size of it. So if we adjust the size and say fig equals plt.figure, and say fig size equals 40, 10. Let's rerun that again, and we should get a little bit nicer of a decision tree there. And so what we've done is we've created a decision tree that's using these 4 variables here to try and predict home price. And so we always start with the root node at the top, and we look at what's the first term of the root node. So it's total living area. So if your total living area is less than or equal to 1,536, then you go down the true branch here. If it's false, if your living area is greater than that, you'd go down the false branch here. And so let's say we had a 1,000 square foot home that was in jurisdiction number 1. Well, we would say 1,000 is less than 1,536, so we'd say true. And then we get to this decision node here, and we have total living area of 1,000, which is less than 1,257. So we'd say that's also true. And then jurisdiction, we were in jurisdiction 1, so jurisdiction 1 is less than jurisdiction of 2.5. So we'd say that's also true. So for our 1,000 square foot house that's in jurisdiction 1, it looks like our estimated value or our estimated price is $154,054. We could also, instead of using the decision tree to walk through and get predictions, we could also just write an equation to do that as well. And so if we set that up, we're going to call it predictions. And if we said pd.dataFrame, and then inside this data frame, we're just going to say total underscore living underscore area colon, and then let's say in our bracket here, we're going to say 1,000. Then we're going to say jurisdiction, and make sure you follow the same order that you have up here in the model. Otherwise, these values will not correspond to what's in the model. So we're going to say jurisdiction, colon, and then we're going to say 1. And then we're going to say residence underscore type, colon, and then we're going to say, let's say our house is a 2-story home, so we're going to say 2. And then lastly, for bedrooms, we're going to say, let's say we have a 3-bedroom home. All right, so then you just close the brace on there and then close that. And then what we're going to do is we're going to say print dtree.predict. Then we're going to predict the predictions. So if you run that, it comes out with 154,054, which is exactly what we landed on when we did this. We have a 1,000 square foot home. So 1,000 is less than 1,536, true. 1,000 is less than 1,257, true. And we're in jurisdiction 1, true. Let's say our home was 1,800 square feet. We were in jurisdiction 2. We had a 1-story home, and it was 4 bedrooms. We can just replace the terms in our equation, run that, and we'll get a different output. If you wanted to double check, we could just say, okay, 1,800 is greater than 1,500. We come down here. Total living area is less than 2,496, true. Residence type is greater than 1.5, that's, or less than or equal to 1.5, that's true. And so we arrive at 285,961, which is exactly what we got here. But sometimes you might make a decision tree that's so big that you can't actually use the tree. So what we need to do is use our test data set to see how well our decision tree models the test data. So what we're going to do is we're going to just add a new column to our y-test data set here. So if we were to look at that, what we're going to do is we're going to add predictions and stuff it right next to this price column in our y-test data set. So if we say y underscore test and call it prediction, and then we say equals dtree dot predict, we're going to say x underscore test, and you can come just right up here to what we did in this model. And when we fit it, just copy the 4 variables, paste them into here again, close off the double brackets, close off the parenthesis. And then if we can just say ytest.head after that. So now we get, for every price, we get a prediction using that decision tree that we just created. When we look at the first 5 rows here, it looks like it's actually doing a fairly good job. It looks like it's getting a pretty close prediction. But to really test how great it is, we're going to need to use the mean squared error. So if we said np.square root, and then we said mean underscore squared underscore error, we said y underscore test, and we're going to say price, and then we did y underscore test of prediction, Then close off the double parentheses there. And what this will do is that'll give us the error of the mean squared error of the prediction here compared to the price. And it looks like on average, our decision tree is about $68,000 off when it comes to the predictions. Now that seems a little bit high, but we did only create a decision tree that had a max depth of 3. You could come up here and change this. If we wanted to change this to a max depth of 6, we could just change that max depth to 6, just rerun everything that we did. And this might take a second on your system to process the actual decision tree because it's going to be a lot bigger now. It's going to have up to 6 levels below that root node. You can see we quickly blew up our decision tree. It's pretty unusable, so we're going to have to rely on using this prediction equation to do any sort of things here. And so if we run that again, we get a little bit different of an estimate. We can run our predictions again, get different predictions, and then we can then run our mean squared error. And it looks like when we increased the decision tree to 6 levels, our error went down to $60,000. So that's the one thing about decision trees. The more depth you add, the better fit it's going to get. But just be aware, the more depth you add, the overfit you could get as well. Which with the overfit meaning that you're only fitting the training data, you're not actually getting a good fit on the test data. So that's just something to be aware with decision trees. It's easy to overfit the data sets. That was just a quick tutorial on how to build a regression decision tree in your Jupyter Notebook. If this video was helpful, I really appreciate it if you could like the video and also subscribe to my channel. That way you get future content that I'll be posting on data science topics. Thank you for watching this video, and please check out my channel.